This video is on the objective make a conclusion and interpret the results for testing the difference between means for paired data, right, or dependent samples. And this is using the critical value or rejection region approach. Now this is the second video on a question related to this objective. Hopefully you watched the first one because I'm not going to do as much explaining in this one. We'll take a look at the question now. So if you're unfamiliar with the topic still, want to see more about it, right, click on more instruction, look at their videos, their notes, their examples, and hopefully those help you. Alright, so here a researcher wants to compare the heights of males between generations to see if they differ. To do this, he samples random pairs of males who are at least 18 years old and their fathers. Right? So there's the dependency there, right? The relationship between these samples. He then splits them into a sample of fathers and a sample of sons. Suppose that data were collected for a random sample of 11 pairs of fathers and sons, right? So that means there will be 10 degrees of freedom with these 11 pairs. There will be 10 degrees of freedom for the student's t-distribution we'll be working with, where each difference is calculated by subtracting the height of the son from the height of the father. Right. Assume that the heights are normally distributed. And again, that's because the sample size isn't very big. There's only 11 pairs. Here are 11 differences. So if the heights are assumed to be normally distributed, we can still say we're going to be working with that student's t-distribution. All right, the test statistic, right? So they're giving us the test statistic here. We don't have to calculate it ourselves. Is a t-score of 1.971. The significance level, alpha, is 5%, 0.05. And the corresponding rejection regions are, any t-score less than negative 2.28 will be a rejection in the rejection region, and any t-score greater than positive 2.28 will be in a rejection region, right? This is a two-tailed test, as you can see from the hypotheses, right? The null hypothesis is that, the average difference between all pairs of fathers and sons is equal to 0. So this means that there's really no difference between heights of fathers and sons, And the alternative hypothesis is that the average difference, in heights between fathers and sons is not 0, meaning that there is a difference in some way between the heights and generations. And the two-tailed tests, right, not equal. That's why you got the two rejection regions. Now, look at our test statistic, 1.971. Does that fall in either rejection region? 1.971 is not less than negative 2.28, right, that left tail region. And it's not greater than positive 2.28, so it's not in neither of these. So our test statistic is not in a rejection region. So we fail to reject the null hypothesis. Now, if you don't reject the null, right, that means I'm keeping this statement. I'm keeping it. And if you keep this statement, that means you're not keeping the alternative, or you're not supporting it. Saying that there's not enough evidence to support this statement. And this statement was what's being tested. This statement is that, there is a difference in heights between fathers and sons, or there is a difference in heights between generations. We're not supporting that. We're keeping the null. So there is enough evidence to support that statement? No. There is not enough evidence to support that statement at the 5% level of significance based on these results. All right. So again, pretty simple, these questions, because they gave me everything I needed. They gave me the test statistic. They gave me the rejection regions. So it's just up to you, do you reject the null or not? And then based on that, would you support the statement that's being tested or not? And hopefully it's pretty easy to determine. You've seen a bunch of hypothesis testing by now, I'm hoping. So hopefully this is becoming simpler and simpler. And hopefully listening to me here, looking at more instruction if necessary, reading the answer explanations when they come up. Hopefully all this stuff is helping you when you go about doing this work on your own. And thank you very much for watching.